Alright, this one for period 3, guys, we already did this. So the sub will pass out to your paper with your name on it. But the rest of the class, period, for period 4 and period 5, we have not done this. So make sure you have, you know how to do this. Most of you can get here because we distribute. Here's where the mistake is. That's 2x minus 4x. We call that combining like terms. We get negative 2x minus 3 equals to 16x minus 8. Okay, get rid of the smallest variable. That is, this is the smallest one, so we minus 2x minus, actually add 2x to make 0, add 2x. You get 18x minus 8 equals to negative 3, because 0 minus negative 3 is negative 3. Now add 8, make that equal to 0. 18x equals to 5, divide by 18, divide by 18. X equals to 5 over 18. This is called one solution. Okay. This one here, these right here, you combine like terms, change, you get negative 5, 4m equals, this here are alike, combine them, you go 6m minus 2m is 4m, add the 8, get rid of the smallest variable, they're the same. If they're the same, it's either infinite or no solution. If the coefficient is the same, 0 minus 5 is negative 5, 0 plus 8 is a positive 8, no solution. Okay, this one here, you need to distribute first. You get 6y minus 9. For those of you who, I'll pan back in a minute, write slow, I'll try to go back. Plus 10 equals to, okay, we can combine these together. Negative y, that's a 1, negative 1y. Plus 7y, we get 6y plus 1. Okay, this here, we combine these two together. You get a positive 1. 6y and positive 1 equals 6y plus 1. This is infinite solution because both sides are the same. It's called infinite solution because both of the sides of the equal sign are the same. Infinite solution. Both sides are the same. Now, if you want to not write all of that, you can just go minus 6y minus 6y, 1 equals to 1. Same thing, infinite solution, okay, whichever way you want to do it. So I'm going to have here, if you're in period 3, make sure you get these answers right. The rest of the period, make sure you copy. Okay. You're going to be using a protractor, so please pass out the protractor to everyone. Right here, you'll need a protractor. Don't break it. I want it all back. Okay. We'll wait. You put this on pause while I go and explain the rest. Determine the length of each side, A. Determine the length, so find the length, each side of triangle NTH. Okay, use your protractor. I can't show this on the iPad because you can't see it, but you use your protractor and measure it using the inside of the protractor, the centimeter. Inside it should say centimeter, cm, in the inside of the circle, the half of circle, semicircle, the inside it says centimeters. And then measure, let's measure first NT. Measure NT. Okay, let's say the measurement of NT equals to, M stands for the measurement. Let's see, we'll just put line segment NT. Line segment NT, let's measure that. I have it at about 2 centimeters. So this NT, I use the inside of the protractor, remember, it's 2 centimeters. Okay, I'm going to measure now HT. HT, line segment measurement is equal to, normally we put an M measurement, line segment NT. Well, anyways, use starting from 0, you measure it, and I get it at 3, right? Let's see, make sure I get it. Yeah, 3. I hit 3 centimeters. From dot to dot is 3 centimeters. Okay, now we can find the measurement of NH by using Pythagorean Theorem. We can do that. A squared plus B squared equals to C squared, or we can measure it. Let's see, let's measure it. It's 3.7. Let's do Pythagorean Theorem and see, check, make sure it's close. 2 squared plus 3 squared equals C squared. 4 plus 9 equals C squared. 13 equals C squared. The square root. See the square root of 13. Where's my calculator? This is my husband and their sport business. Golf, navigation, game. Honey, where's my calculator and all this? Here it is. What? Clear. Cancel. Square root of 13. 3.6. See, it's close to 3.7. Let's use the Pythagorean Theorem answer because it's closer. Anyway, 3.7. 3.6 is N to H. Alrighty? Alright. So, translate. So we measured it. triangle 9 units down. Go down 9. So each one go down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, that, just put that n prime. And this one, t would be here. T prime. It's 9 down also. Oops, let's erase it. All the other marks. And then 9 down. For t would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, 9. Oh. Aha, this one would be h prime. Okay? How would the length and sides of the image compared to the length of the side of the pre-image? Okay, now this is called a pre-image. Okay, the original one, so make sure you write this down on your notes. Okay, that's the pre-image, and this is how would the length of the side of the image, this is its image of that one, compared to the length of the side of the pre-image. How do they compare? They're the same. If you measure it, measure NT, this is the exact same length. We call that congruent. Okay? So the image is congruent to the pre-image. That means if you measure it and everything, it'll be exactly the same. Okay, rotate it 180. Okay, would be T would be here. I should put some number in, huh? Makes it easier. H should be here. And N would be here. What do we know? We'll label this image 2. This is an image of this one. Right? It's an image of that one. 180, remember the number stays the same. Numbers same. About the origin. How would the length and sides of the image compare? How would compare to the pre-image? So how does this one compare to the pre-image? They are congruent. Even though you rotate it 180, the image is congruent. Use the word congruent. Congruent means the exact same size and shape to the pre-image. There's no change. Same thing here. Reflect this over the y-axis. Okay, let's put that. This is image number 2. Let's put image number 3. Reflect it over the y-axis. So remember, it's like a mirror. Reflect it over right here. That's H. T would be right here. And N would be 7 away. right there. How does it, oops. Okay. This is called image number 3. Okay, let's color it in. How would this compare to this pre-image, the blue? I'll take this out so you know what I'm talking about. This blue right here. How do they compare? It says, how would the length of the sides of the image compare to the length side of the pre-image? Measure them. You can measure this right here, and it'll be the same length as NT here. Measure it, you'll find that it's 2 also. Measure this here, you'll also find that is 3. We call that congruent. The image is congruent to the pre-image. There's no change. Keeps it congruent. Image is congruent to the pre-image. Even though in your mirror it still stays the same, nothing changes. So we come to the vocabulary word congruent line segments. Are line segments that have the same length. See that? These are line segment. This symbol here is line segment. Congruent line segments have the same length. Okay? All right, that's important. So I'm going to have you copy this, put it on pause while the protractor should be collected at this time. Make sure the protractors get back in its spot. So put it on pause. Okay? Here, write the congruent line segments. Congruent line segments are the line segments that are the same. So here's 8 AB, line segment AB is congruent to, here you put the symbol there for congruent instead of equal. That symbol tells us we use the word congruent. Okay? Congruent to, this is also 8 right here, DE, line segment DE. Okay, another congruent, look at here, BC is 6, I'll change the color, BC is 6, so line segment BC is congruent to, remember to put a little squiggly line, to line segment EF, because look, they're both 6 feet. The last congruent line segment is 10, 10. So this 10 is called line segment BC is congruent to line segment DF. Okay? Corresponding sides. Very important you understand corresponding sides. Okay? Because these are the same length, AB corresponds to DE. So you would say AB corresponds to DE. Okay, and then here you would say BC corresponds to Spelled this wrong, so sorry. EF. Okay. AC right here corresponds to DF. Okay, they basically same length, same side, corresponding sides. What would you predict to be true about corresponding sides of a congruent triangle? They're congruent. Corresponding sides are congruent sides. Congruent. Okay, this one here, problem 2. If you gone on your own after this, I would assume you know how to do these. All right, let's see. A is 810. Oops, too big. A is 810. So letter A. Okay. 1, 2 is letter B. And 8, 2 is letter C. Connect them. There's your triangle ABC. Okay. Determine the length of AB. Determine the length of AB. When you see the word length and it's a right triangle, like right here, you use A squared plus B squared equals to C squared. I'm going to have you finish that. You count the squares. Okay, if you've forgotten. 1, 2, 3, 4, 5, 6, 7. 7 squared plus 1, 2, 3, 4, 5, 6, 7, 8. 8 squared equals to C squared. 49 plus 64 equals to C squared. Finish this. Okay. Alrighty. You should be able to finish. Use a calculator. Okay, and get it done. Okay, translate. Translate means to slide. 10 units to the left. Okay, triangle and ABC 10 units to the left. Form triangle DEF. So A becomes D, B, okay, A is D, so it goes 10. This way is 8 already right here. 9, 10 right there. 10. So 10 would be, okay, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 right there. So I'm going to, right there, get rid of all these little dots. These things I used to count. Okay, and then A, instead of writing A prime, you put D. Uh-oh. How many minutes has it been? Okay, and then B is letter E, so you go 10. 1, 2, 4, 5, 6, 7, 8, 9, 10. And here is letter C. C is straight. Oh no, that's not B. B, it's E. Letter E. And the other one, the last one for C, is letter F. Okay? Letter F. So, straight down from D, because A and C are directly right there, that's letter F. That's how we do it. Connect them. Okay, we got it. Side C, AC corresponds to what side? AC corresponds to this DF. What is the problem situation? Okay, the problem situation is to identify the same side. Find the letters or the variable letters that make AC on the other triangle. Okay, what is the problem situation? Find the letter on the other triangle. Find the letters that AC, find the letters that AC on the, that makes AC on the other triangle. Okay, so the other letter that makes AC is DF, which is DF. D, so you can see it, DF. Line segment DF corresponds to AC. Okay? What is the problem situation? It's asking side BC corresponds to what side? Okay, so side BC corresponds to find the letter or letters on the other triangle that is the same or congruent, that is congruent. We want to use the word congruent to BC. So on the other triangle that's congruent is EF. So put line segment EF. Okay, it corresponds to this. Okay, what's the problem situation here? AB corresponds to which? To what? Same thing. Okay, rewrite it and find it. AB corresponds to ED or DE, right? Line segment. What's the problem situation? Copy one of these. It's fine with me. Identify congruent sides. Okay. Identify congruent sides is them wanting you to do this right here. Okay. Identifying congruent sides. Okay, so we know congruent sides. AC line segment is congruent to the equal sign with the little squiggly DF. Right there. Okay? Because these and these are congruent. Okay? Next one is BC. If you look at my letter, what I'm circling up here, BC, line segment, is congruent to EF. And the last one is AB. AB right here is congruent to ED, DE. AB is congruent to DE, line segment. You don't need to write a congruent statement. We'll skip those. I need you to write identifying congruent sides. Okay? Identify, okay, what transformation creates that? So I'm going to put this up for those who needs to copy. Wait, put on pause, wait for you to identify those. Transformation, okay, it's a reflection over the x-axis. So if you put the mirror here, it's the letter X, so it's reflection. Don't just put reflection, there's different types of reflection over the x-axis or across the x-axis. Identify, you don't need to write congruent statements. Identify congruent sides. Okay, let's see. Let's start with AB. AB, line segment AB is congruent to, make sure you put this little squiggly line, XY. Okay? Okay, next one. Let's do BC is congruent to, oh no, this is not XY, this is XZ. XZ, wrote too fast, because this is XY. And then our last congruent statement is AC is congruent to YZ. ZY. AC is congruent to ZY. Okay? Find the length of ZY. Find this length right here. We use a squared plus b squared equal a squared plus b squared equals to c squared. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 6. So make sure you do that one at home for homework. Do not leave it blank. Okay, same thing here. You don't need to write congruent statements here. Okay. Identify the transformation that occurred. Oh, that's also a reflection. Wow, I gave you two reflections over the x-axis again. Okay, reflection over the x-axis. Now you should be able to do this on your own after this. Okay, let's do this one here. Okay, this one is looks like a rotation of 90 degrees. To me, I see it this way. So counter. If you see it this way, it's clockwise, right? 8 and 8, 2, 2, 8. Yeah. Okay. So either way you see it, or you can see it a rotation of clockwise 270 degrees, whichever way you see it. So this is definitely a rotation. I'll put rotation counterclockwise 90 degree. Rotation 90 degrees counter clock. Identify congruent sides. Okay, let's see. This EF is congruent to GH. And ED is congruent to GP, line segment GP. And then last one, DF is congruent to HP. Okay, that's how you do congruent sides. So make sure you finish this one and you do the Pythagorean theorem on this one. And anything else left blank,